Ever wondered how the seemingly abstract concept of an ellipse finds practical application in our everyday lives? Well, as it turns out, this shape, defined by two foci, is more common than you might think. It's a concept that's not only intriguing, but also surprisingly practical. An ellipse, in its simplest form, is a plane curve surrounding two focal points. It's a shape that's a bit like a circle, but stretched out. You can imagine an ellipse as a circle that decided to go on a diet on one axis, or as a circle who's had a bit too much to eat on the other. But this isn't just a shape confined to the realms of abstract mathematics. It's a shape that has real-world applications appearing in places you probably wouldn't expect. For instance, have you ever been to a dentist and noticed the shape of the light above your head? That's right, it's an ellipse. The light is designed in such a way to ensure it illuminates your mouth effectively without blinding you. It's a brilliant example of how an understanding of ellipses can have practical applications. Similarly, if you've ever had the chance to visit the National Theatre of São Carlos, you'd have noticed its elliptical shape. This unique design isn't just for aesthetics. It helps distribute sound effectively throughout the theater. The acoustics work in such a way that sound emitted anywhere in the theater reflects towards the other focus, ensuring the king's ears are pleased. The beauty of ellipses lies in their simplicity and their complexity, in their theoretical underpinnings and their practical applications. They provide us with a fascinating lens through which to view and understand the world around us. So whether you're a math enthusiast, a curious observer, or simply someone who enjoys learning about the world, this exploration of ellipses promises to be an enlightening journey. So let's dive in and demystify this mathematical concept. First off, what is an ellipse? You may remember it from your math class, but let's revisit it. An ellipse, in the simplest terms, is a shape that resembles a squashed circle, a geometric figure that results from the intersection of a plane and a cone. But let's not get lost in the abstract. Instead, imagine you're standing in the National Theatre São Carlos, under the spotlight. That spotlight is creating an ellipse on the stage floor. This ellipse is formed when the light from the spotlight, representing the cone, intersects with the stage, which represents our plane. Now, let's add in some props for a little more fun. Imagine a large ball placed on the stage, right under the spotlight. The stage's surface touches the sphere at a single point. This point, where the stage and the sphere meet, is what we call a focus of the ellipse. What about the other focus? Well, let's place another sphere under the stage, right below our first focus. Now we have two focal points, and something fascinating happens when we bring these 2 points closer together. As the two focuses move towards each other, our ellipse gradually transforms into a circle. That's right, a circle is just a special case of an ellipse where the two foci coincide. Now this might be a bit of a surprise, but when we say that the Earth orbits the Sun in an elliptical path, we're not simplifying things just for the sake of it. In fact, we're providing a more accurate representation of reality. So the next time you look at the moon and notice it's not a perfect circle, remember it's an ellipse. Or when you tilt a glass of water, the water's surface forms an ellipse, all thanks to the laws of optics. So, an ellipse is not as abstract as you thought, right? Understanding the concept of ellipses not only deepens your understanding of geometry, but it also allows you to appreciate the world around you a little bit more. Now that we know what an ellipse is, let's see how it applies to our daily lives. Have you ever noticed the shape of the moon? While it might seem like a perfect circle, it's not. In reality, the moon's appearance from Earth more closely approximates an ellipse. This is due to the fact that the moon isn't a perfect sphere, and this imperfection is reflected in the way we perceive it. Similarly, if you've ever looked at a plate from a certain angle, you might have noticed that it appears elliptical rather than circular. This is not a trick of the eye, but a property of ellipses in action. Think about a glass of water. When you tilt the glass, the water surface forms an elliptical shape. This is due to the principles of optics. The light refracts or bends as it travels from the water to the air, creating the elliptical appearance. Isn't it fascinating how an abstract mathematical concept, such as an ellipse, can have such tangible manifestations in our everyday life? It not only helps us understand the universe around us, but it also provides practical solutions to everyday problems. For instance, consider the lights above the dental chair. These lights are shaped like an ellipse to ensure that the light illuminates the patient effectively without blinding them. This is a practical application of the principles of ellipses to optimize light distribution. Even in architecture, the principles of ellipses are put to use. The National Theatre of São Carlos, with its elliptical shape, is a prime example. The elliptical design of the theater helps distribute sound effectively, ensuring that everyone, from the front row to the royal box, can hear the performance clearly. From the shape of the moon to the design of a theater, the elliptical form is all around us. It's an integral part of our lives, whether we realize it or not. Isn't it fascinating how a mathematical concept can be so visually present in our daily lives? Ellipses also have some unique properties that set them apart. One such property is the existence of a single focal point, which plays a significant role in the behavior of objects within the ellipse. To illustrate this, consider launching a ball from one focus of an ellipse. Now you might think that the ball's trajectory would be unpredictable, but here's where the magic of ellipses comes into play. Regardless of the direction in which the ball is launched, it will inevitably land in the hole located at the other focus. This is not a mere coincidence or a result of luck, it's a mathematical certainty. The reason for this lies in the inherent geometry of the ellipse. The sum of the distances from any point on the ellipse to the two foci is a constant. So no matter where the ball is on the ellipse, the total distance it travels from one focus to the other remains the same. This property is not just a fascinating mathematical fact, but it also has a number of practical applications. For instance, think about a game of pool. The elliptical trajectory of the balls, guided by the geometry of the table, allows skilled players to make seemingly impossible shots. And it's not just in games where this property comes into play. In astronomy, it helps explain why planets in our solar system follow elliptical orbits around the sun. This is due to the gravitational forces at play, with the sun at one focus of the ellipse and an imaginary point in space at the other. In the field of optics, this property is used to design lenses and mirrors that can focus light or sound waves. Think about a flashlight or a car's headlight. The light source is placed at one focus of the elliptical reflector, ensuring that the emitted light converges toward the other focus, producing a well-defined beam. So, as you can see, this unique property of having a single focal point makes ellipses not just interesting from a mathematical standpoint, but also incredibly useful in a wide range of applications. That's the magic of mathematics for you. So where else can we see the practical use of ellipses? Well, the humble dentist's chair is a prime example. The lights above the chair are designed in the shape of an ellipse. This isn't just for aesthetic reasons, it's a practical choice. The elliptical shape allows the light to illuminate the patient's mouth effectively without dazzling them or creating unwanted shadows. And how about the National Theatre São Carlos? Its elliptical design isn't just for show. This theater has two foci, one on the stage and the other near the royal box. The unique acoustics of this shape ensure that sound waves emitted from the stage reflect towards the other focus, pleasing the ears of the king. These are just a couple of examples, but the practical applications of ellipses are all around us, from architecture to optics, and even in the trajectory of the planets. Who knew that ellipses could be so practical and useful? Let's quickly recap what we've learned about ellipses today. Ellipses, these fascinating mathematical constructs, are all around us. They're the intersection of a plane and a cone, forming a closed curve with two focal points. A circle is simply a special case of an ellipse, where both foci coincide. We've seen how ellipses manifest in our daily lives, from the slightly elliptical shape of the moon, to the way a plate or a glass of water appears when viewed from certain angles. We've also discovered that an ellipse has a unique property. If you launch a ball from one focus, it will always end up at the other. We've explored the practical applications of ellipses, like the dentist's chair lights designed to focus illumination without causing discomfort, and the National Theatre of São Carlos, where the elliptical shape optimizes sound distribution. And that, my friends, is the wonderful world of ellipses, a mathematical concept that is all around us even if we don't always realize it.